3. I'll get this, try and finish this off now. So I was factorising this thing here, and I said that you needed the lowest common, the highest common factor out of these ones. So 4 e to the 4x was in both, and then you take the one with the lowest power in, and that would leave me, to get this one, would be 2x plus 3 to the power of 1, and then minus, because that times by that would add up to give 6, and then minus 4 times what makes 12, 3, and that's it. The rest of that stuff is already there. So bracket goes round that, that's all over 2x plus 3 to the power of 12. Now, there's two things I'm noticing here. This bracket's on the top and the bottom, so I'm going to cancel that out there, cancel that. 5 and 12, we add and subtract, so that will now become just to the power of 7 on the bottom. And then anything to the power of 1 is just itself, so it's 2x plus 3 minus 3, so they're going to cancel as well. So then finally, I'm going to expand that bracket, which times it by the 2x, so it's going to give me 8x e to the 4x all over 2x plus 3 to the power of 7. You know, that was a full-on question. That was not easy. Okay, let's look at the marks. What are we on? We're on 4 marks. So that you'll be picking up a lot of the marks for getting as far as this stage here. That'll probably only be worth 1 mark, those 2 lines there. So if you're getting into a fuss about that bit there, it's probably not that many marks. Okay, we'll have a look at it in class anyway properly. So the next question is integration. So that is the inverse process of differentiation, so it should be quite simple if you know your differentiation well. So let's start 7a. So we've got the integral of e to the 5x over 6 dx. Now we like e to the x because whenever you integrate it, what am I looking for here? You just leave it exactly the same, so it's going to say e to the 5x. Now, you divide by the power, so you're going to divide by, or the differential, sorry, not by the power, divide by the differential of the power, so you're going to divide that by 5 over 6 plus c, and I'll neaten that up. When you divide by 5 over 6, it's like times by 6 over 5, so it's going to become e to the 5x over 6 all over 5 plus c is a sort of a slightly neater version. Part B, now, I'm not going to write it down like that, I'm going to write it into a bracket because I can't integrate things unless they're as indices. So it's going to be 8x plus 1 to the power of a third dx. So that is going to equal. Now it's going to equal exactly the same bracket, but the rules of integration are power up by 1, so it's going to become 4/3, divide by the new power, but also times by the differential of the bracket, plus c. I'm going to neaten that up. That 4 times by the 8 is 32, and that 3 I'm going to take up onto the top. So it's going to become 3, 8x plus 1 to the 4/3 all over 32. Okay. For part C, I've got sine, so this is where my front sheet comes into handy again. So sine integrates to minus cos, so let's remember that. Sine integrates to minus cos. And if I write down what the question is, it says sine bracket 1 minus x over 3 dx. So it's got to become minus cos to exactly the same thing, okay? But just as I said before, the power goes up by 1, divide by the new power, and then times by the differential of the bracket. Well, there's no power here, so we don't have to worry about that, but you do need to divide by the differential of the bracket. So what is the differential of this? Well, it would actually be minus 1/3, and don't forget your plus c. Dividing by a third is like times by 3. Minus and a minus makes it plus, so it actually becomes positive. So it's 3 cos 1 minus x over 3 plus c. And then for D, this was actually part 1, 2, and 3. So this is really part B, but I'm just going to leave it as that. Now, we know to integrate things when you have limits, that you sub in the numbers and you do the top number, take away the bottom number, and it gives the answer. They've told us what the answer is, okay? So we need to do that and set up an equation for it and solve that effectively, okay? So we're going to get the integral between a and 2 of 1 over 4x minus 1 dx. Now, if there's no power on the bottom here, we don't change that to just 4x to minus 1 to the power of minus 1, because that power will go up to 0, which would effectively be 1. It must have had something to become this thing. If it's ever got no power on the bottom, it always becomes ln, Okay. Now technically you should have mod signs here, but mod signs make things positive. The 2's positive, and we're told in the question that a is greater than 2, so we don't strictly need those mod signs there. You also divide by the differential of the bracket, so we need to divide this by 4. Now this would then go into square brackets, and I'll put my limits in here, which is a and 2. So I'm now going to sub into that to 4, and I'm going to just put brackets in now to make it easier. So for a, because I've subbed in a for x, minus 1 all over 4, take away ln of 4 lots of 2, so that's 8, take away 1 is 7, all over 4, equals, now I actually know from the question that equals 0.284. So that equals 0.284. So I'm just going to solve this now. So I'm going to take that over and add it, and then I'm going to times it by 4 to get ln of 4a minus 1. And in the calculator, I'll show you what I'm writing. So I'm going to write 0.284. I'm going to take this over first, so plus ln of 7, and then that divided by 4 comes to that. I'm then going to bring this divided by 4 over and times that by 4. So that becomes 3.0819 blah blah blah. I'm now going to take ln over, and that's going to leave me 4a minus 1 is equal to e to the power of 308,194. I'm going to put that into my calculator as e to the power of ans. And then I'm going to just try and solve in one go here. So I'm going to take over the minus 1 and plus 1. So I've now got that answer, and then I'm going to divide that by 4, which gives me 5.7 to 1 decimal place. And I'm assuming that's what they want to do. Look at all those zeros, it feels like it's too close to be lucky. And when it's said to 1 dp, I mean that's filling me with confidence. Okay then, number 8, some mod signs. Okay, now the trick that you can do to make this really quick is, let me write out the question first. So mod of 3x plus 4 equals 2 mod minus 3. Now I don't like the mod signs. Okay, if they're brackets, it'd be easy. I'm going to change them into brackets. But to do that, once I must treat the mod sign as positive, and once I must treat it as negative. But you only need to do it on one set of these, either this one or this one, and it will give you both solutions. You could go and do it where you take the positive this, the negative this, and the positive this, and the negative this, but they always end up working out to be exactly the same answers. So you only need to just choose one side. I always choose the one that's all encompassed within a mod sign. It's where I take the positive version of that and the negative version of that, and then you just change it to brackets. Okay, so I'm going to have, so for my positive version, I'm going to have 3x plus 4, where I just treat it exactly what it is equal to 2 brackets x minus 3. I'm going to expand those brackets to get 2x minus 6, and then I get x is equal to minus 10. And then my minus solution, I treat this to being the opposite signs of what they both are. So this will become minus 3x minus 4 is equal to 2 bracket x minus 3. So minus 3x minus 4 is equal to 2x minus 6. So then I'm going to get 2 on this side. I'm going to get 5x on this side. So 2/5 is equal to x here. Okay, done. The next one, we are on to our functions. So 9. And we are asked to do an inverse function. So we're given this thing here. So inverse functions are graphs that are reflected in this dotted line, which is y equals x. Okay, and it says find an expression for f minus 1 of x, and then write down the domain of that. Okay. So the way to do it is to change the f of x to y. So we get y equals 1 plus 2 over root 3x minus 5. So that's exactly the same thing as I've got there. Okay, but all I've done is change that to a y. We rearrange this now to make x the subject of the formula. So I'm going to get y minus 1 is equal to 2 over root 3x minus 5. I'm then going to take this over as a times, but then I'm going to bring this over as a divide. So I'm just literally going to swap those two. So 3x minus 5 is equal to 2, and then y minus 1. I'm then going to take the square root over where it will become squared. So it's going to become 2y minus 1, but all of that thing squared. I'm not going to actually expand that. I'm going to leave it as that, because otherwise it'll take me ages. And then I'm going to take the rest over in one go. So 2y minus 1 squared, and then it's plus 5, and then the whole thing is going to be divided by 3. And that is my f minus 1. But I change the y to an x, and that's just the rule. That's how you do it. It was quite nice this time because I didn't have to choose. Like if you took over a squared and made it square root, you have to choose if it's plus or negative due to the domain that you have. But we didn't need to worry about that. So all good with this one. So that's got me 4 marks. And then to get the domain of f minus 1, so it says find the domain of f minus 1. It's the range of this thing here. So I just need to sub in 7 and infinity into that. And then that will give me the range of f of x, which is also the domain of f minus 1 of x. So I'm going to say f bracket 7, and I'm subbing it right into that thing at the top, so that f of x thing. So it's going to be 1 plus 2 over root. So it's 3 times 7, which is 21, take away 5, which is 16. So 2 divided by root 16, what's that? 4, so it's 1.5, isn't it? And strictly speaking, shouldn't have 2 equals on one line, so I'll change that to an arrow. And then f of infinity, now be careful here, as people just say, oh, it's always infinity, not strictly true. It's going to be, the square root of infinity is infinity, and then anything divided by infinity actually goes to 1. So the answer is 1, okay? Sorry, anything divided by infinity is 0, so 1 plus 0 being 1. Now you have to write your domain in ascending order, so it's going to be 1, 1.5. We now look at 1. 1 belongs to infinity. Infinities always have rounded brackets, so that must be a rounded bracket there. 7, what sort of bracket did 7 have? 7 had a square bracket, so this must have a square bracket round here. Okay, so I would just say, therefore, f minus 1, f to the minus 1 of x domain is equal to brackets 1, 1.5. Okay, and finally, number 10, we've got some normal function now, composite functions. So f of x, so it says by considering g dash of x, show that it is an increasing function. Now g dash just means the differential of that. To do that, I need to rewrite g of x. So g of x as a power. Now, don't confuse what I was just saying about integration, where we wouldn't bring it up, become ln, that's integration. We're differentiating, which is the reverse process. So this is effectively the chain rule if you want to use that. So I would times by the power of the bracket, I would reduce the power by 1, and I'd also times by the differential of the bracket. The differential of the bracket is 1, so nothing to worry about there. So I'm going to get minus 4 times by minus 1, so that's the power of the bracket. Then that bracket again, but you reduce it to minus 2, so reduce the power by 1. So we're going to get here positive 4 over x plus 1 squared is g dash of x. Now, what does it mean when it says it's an increasing function? Well, take g's range. So g's, not g's range, so g's domain here. It is minus infinity to minus 2. So if I chuck in any number between minus infinity and minus 2, what happens? Well, I'm going to get a positive number because any number squared is always positive. So I get a positive, and then divided by a positive, what does that give? Well, that always gives a positive number, doesn't it? Admittedly, it could be a very, very, very small positive number, but it's positive nonetheless. So therefore, we will always have a positive differential. Therefore the gradient's always going to be a number, hence it's always getting bigger, hence it's always an increasing function. So we have increasing function. Okay, so that's part A. Part B, find the range of g. So find the range of g. We want to sub in those numbers, so minus infinity and g of minus 2, not g dash now, back to this thing, okay? This original thing by here, okay? So it would be minus 4 over, and then it's going to be minus infinity, and then plus 1. Now, as we just had before, minus infinity plus 1 is minus infinity, and if you divide anything by infinity, it is going to become 0. So that's 0. And then this one here would be minus 4 divided by minus 4, but divided by minus 2 plus 1. So that's actually going to be minus 1. Minus 4 divided by minus 1 is plus 4. Okay? So my range for G is 0, 4, 0 belonging to infinity, which was a round bracket, and then 2 was a round bracket anyway, so don't need to worry too much about the round brackets this time, both round brackets. C. Write down the domain and range of f of G. Okay, so you have to remember some rules, and if you check the Twitter page, there's a really, really good rule that was written up by Grace. So check that if you want to check the rules. So it is always the domain of the second letter. So f of G domain is simply just G's domain. So it equals minus infinity to minus 2. You don't need to write down in bracket G's domain like I'm about to. I'm just doing that for you, okay? G's domain. To work out the range of this thing, f of G range, you would sub in what G's range is, because G will chuck out these numbers between 0 and 4, and then we will sub those into the first letter. So we'll sub 0 to 4 into f. So I need to do f of 0, and I need to do f of 4. So I'm going to get, what am I going to get? F of 0, so I'm going to get root of 5. And I'm going to get, this one's going to be bigger, isn't it? 4 squared is 16, 16 plus 5 is root 21. Now, I would look at those numbers in the exam and think, oh, I've probably gone wrong there, but honestly, you haven't, I swear. I remember these answers from before. It is root 5 and root 21, okay? So you write it in ascending order. Do I need to worry about the brackets? No, they're all round brackets, so round brackets, lovely, okay? Part D, part 1. Is what have we got? It says, write down an expression for f of g of x. So f of g of x, now the best way to write this is just whack a bracket around the second thing and then change it to f and then just chuck in whatever g of x is. So g of x is this minus 4 over x plus 1. And then wherever you see an x in f, you change it to this thing here. So big square root sign is x squared, so minus 4 over x plus 1 squared. And then plus 5. Okay. Now, what does it say there? It says, hence solve. Now, that is an expression. There's no need to further simplify that. I usually get myself a little bit fussed by trying to solve that, but that is an expression for it, okay? So for part 2, it says solve it equal to 3, fg of x. Just check as well, because I've seen them do this a couple of times, that they are in the same order. So they ask you to do that one, but switch the letters here. So just watch out for that. It's fine. They've kept it the same, okay? So I'm now going to put that equal to 3. The first thing I'm going to do is take the square root over and square this to get 9. So 9 is equal to, in fact, actually, let's take this, if I take that over and square it and get 9, let's take this plus 5 over and take away 5 straight away. Now that is going to be equal to minus 4 x plus 1 squared. Now hold on, don't try and square this yet, because what's 9 take away 5? It's 4. Take the squares over now, it becomes plus or minus the square root of 4 is equal to minus 4 x plus 1. Okay, so we've got our two solutions here. So we're either going to have plus 2 or we're going to have minus 2. So here's my first solution, minus 2 is equal to minus 4 over x plus 1. And then my other solution is 2 equals minus 4 over x plus 1. Okay, so I'm going to just solve both of those. I'm going to try and squeeze it in just by here. We'd switch those two. So it's going to become x plus 1 is equal to minus 4 divided by minus 2, which would be plus 2. Take over the plus 1 to be minus 1. So x would equal, I just had it then, x is equal to 1. And this one here, this would actually give a minus 2 solution. And then take over the plus 1, and x would be equal to minus 3. Okay, but you should be able to work that out yourself anyway. I know I haven't gone through it in detail, but you should be fine with that. If you're not, give me a shout and we'll go over it in class. Now, hold on, one of these solutions may not work. We're doing f of g. The second letter has to be its domain. F of g's domain is between minus infinity to minus 2. So 1 does not fit that, because domain is a posh word for the x values, range is a posh word for the y values. So it is not that one, as not in FG's domain. And that, I believe, is the end of the paper.